Hello and welcome to today's class. My name is Dr. Wanjala Titus. Today I will be taking you through statistics and probability. Therefore, in the previous class, we were able to look at the binomial distribution, the exponential distribution. We were able to look at the Poisson distribution and many other distributions. But today we'll be looking at the uniform distribution. And out of this uniform distribution, we are going to look at this one statement that will guide us. This statement says a random variable x is said to have a uniform distribution on intervals a and b if its probability density function is given by this one. Then, in an exam, you'll find a question asking you to derive the mean and variance using given the random variable x following a normal distribution. Therefore, let us now straight away derive the mean and variance. But if you haven't subscribed into my channel, take a second, subscribe so that in case of a new information, you'll be the first one to be notified. Okay, thank you. Therefore, as we all know, mean is given by depending on a given random variable. But since this is a continuous random variable, we are going to involve the integral signs. So we will have the mean will be given as the integral from a to b. Are we getting x? Then multiply by the probability mass function or the probability density function. But we all know what is this one. Are we getting it? Therefore, let us now replace that one. Then our expected value of x is going to be the integral from a to b. We have x multiplied by 1 out of b minus a dx. Of course, here is also supposed to be dx. Are we getting it from there? This is now f of x, which is this one. So we replace it here. But this is our constant. Let us eliminate this one to the other side. We'll have the expected value of x being equals to 1 out of b minus a. The integral from a to b, we have x dx. So in calculus 2, where we have inferential differentiation, we will have to integrate this one directly. For example, given a value, we integrate the value of q raised to n. When we integrate this one, we will say it will be q raised to n plus 1 out of n plus 1. That is integration. Therefore, we have to integrate this one. We will still have the expected value of x is going to give us 1 out of b minus a. Are we getting? Into this one now, it's going to be x squared out of 2. Here we don't need c, but b and a. Are we getting it clearly? Then what we do is we have now to replace the value of a and b, or the intervals. We'll have now 1 out of b minus a, then multiply by b squared minus a squared out of 2. That one will give us this. But remember, b squared minus a squared can be also written as b minus a, b plus a. That is identities. And therefore, we replace this one with this one in the above equation. Then we will have b minus a, b plus a, all over 2 into b minus a. Are we getting it? Then this one will cancel out this one. So our expected value of x, or the mean, will be given as b plus a out of 2. This is now what we call the mean of a uniform distribution. Thank you. Let us now look at the second derivation of variance. And variance is always given by the expected value of x minus the expected value of x. This is squared. But we all know this one, we have already found the mean as this one. Are we getting it? So we have to find this one in our calculations. So let us write it. This one, expected value of x squared, is going to be the integral from a to b of x squared f of x. Are we getting it from there? Yeah. Then we do what? We replace the value of f of x, which is the probability density function. Then this one is going to be the integral from a to b. We have x squared multiplied by 1 out of b minus a dx. Are we getting it? So this is our constant. We have to put it outside, which will be b minus a. The integral from a to b, we have x squared dx. Are we getting it? So in reaching there, we have to integrate this one directly. Well, how are we going to do it? It's going to be 1 out of b minus a. Then we say it's going to be x cubic out of 3. See that way? Then close the bracket, b and a. Are we getting it? So when we replace the intervals of a and b, we are going to have b minus a multiplied by b cubic minus a cubic out of 3. Are we getting it? But remember, b cubic minus a cubic can also be written as b minus a, b squared plus ab 2 ab, are we getting, plus a squared. Are we there? So we replace this one with this above equation. So this one is going to be b minus a, b squared plus 2ab plus a squared all over 3 into b minus a. Are we getting it? So in reaching there, this one will cancel with this one. So we will remain with the expected value of x squared is going to give us b squared plus 2ab plus a squared all over 3. Are we getting it now? But initially the question said we should have this one minus the mean. So it's going to be, variance is going to be b squared plus 2ab plus a squared out of 3 minus b plus a out of 2 but square. Are we getting it? But how are we going to have, what if we square this one? So this one is going to be b plus a, b plus a. So it's going to be b squared plus b a plus ab plus a squared. So it's going to be b squared plus 2ab plus a squared out of 3 minus, this one is going to be b squared plus 2ab plus a squared. Are we there? Out of 4. So we have to use the LCM to evaluate this remaining part. Therefore, our LCM is going to be 12. Then this is 12. Here it is going to be 4 multiplied by the whole of this, which is going to be b squared plus 6ab, 8, not 6, 8ab plus 4a squared minus, this is going to be 3b squared minus 6ab minus 3a squared. Are we getting? So when we substitute, this one and this one is going to remain b squared. This one and this one is going to remain minus 2ab, and this one and this one is going to be plus a squared out of 12. 2, yeah, 12. But remember, that one can also be written as, it can also be written as b minus a squared out of 12. So our variance of x will be given as b minus a squared out of 12. That's our variance. Thank you so much for watching. Hope you have enjoyed your lesson. In case of any question, leave your question in the comment section. I will be following so that everyone gets helped. Thank you.